So first I would like to thank you for the opportunity to share my talk with wonderful Li-Fraumeni syndrome families, researchers, healthcare providers, and staff as well. So the title of my talk is Li-Fraumeni syndrome, challenges with the interpretation of TP53 germline variant. And here is the outline for my talk. We have 4 points. I hope each one will take me 5 minutes, so we finish on time. So given a diverse audience, I will start by a brief review of germline variant interpretation guidelines. The second point is to know which database repositories are helpful to support P53 variant interpretation. And then we will understand the challenges related to variants with conflicting interpretation of pathogenicity. We'll give an example from the clinic. And the last point is a question. How can we address the problem, or how should we address the problem? So let's move to our first point. So we know that accurate pathogenicity assessment is critical for counseling and medical decision making. Guidelines for sequence variant interpretation have evolved over the last decade to accommodate the growing challenges of clinical genomics. In 2015, the American College of Medical Genetics and Genomics and the American Association for Molecular Pathologists released a guideline to promote consistency in variant interpretation. And they published a paper in Genetics in Medicine in 2015, and this is a highly cited paper and a reference for healthcare providers who works on interpretation of genetic variants. I will not go through the slide, but this is an important table from that article. It's quite complicated, but it's a key table for the geneticist to help to support the variant interpretation. I will go only through a key point. Here on the vertical column, you see that we have evidence that will help us in determining pathogenicity. So it goes from population data to computational and predictive data, as well to functional data, segregation data, and allele data, and other data. Just, it is important to mention, I will give you only one example. I zoomed into the slide. I removed all the benign so you will be able to see. And as I will give you an example. So if we take this criteria, first let me mention, I forgot to mention one thing here, that the ACMG has developed 2 sets of criteria. One set for benign and the other set for pathogenic. So each criterion was assigned a weight, and the weight will be strong, supporting, or stand alone for benign, and it will be supporting, moderate, strong, or very strong for pathogenic. So now I will go to the next slide and I will show you an example. For example, let's say if you have a variant and it's absent in a population database, for example, the exact consortium, this variant will get a PM2, P for pathogenic and M for moderate. So it is supporting evidence of pathogenicity. So what we do is we combine all the evidence we gather from a pathology report, and we come up with a pathogenicity assessment, and the variant that we are analyzing will fall under one of these 5-tiered class of pathogenicity. You notice that the likely pathogenic are actionable, meaning when we receive a results about a germline variant that is pathogenic or likely pathogenic, we need to counsel the patient/family about screening and risk reduction strategies and genetic testing for at-risk individual. Whereas for benign, likely benign, and variant of unknown significance, we still need to counsel them based on the personal or family history. To add for the variant of unknown significance, we need to follow up on this in case it gets reclassified, hopefully in the future. It could be downgraded or it would be upgraded to pathogenic or likely pathogenic. So this is for the LFS families who are here when you receive, and we receive a pathology report from the lab. This is what we look when we analyze these variants. Now, despite the existence of variant interpretation guidelines, gene curators may reach agreement on variant classification in only 70% of cases. And the outcome of this inconsistency for clinician and patient in such cases is uninformative, unhelpful at best, and at worst, open to a misinterpretation. So the next outline, where do germline TP53 get deposited and curated? In the morning, we heard by Pierre Henault a wonderful talk about phenotype-genotype correlation, and he introduced the IARC database, and that I will talk about a little bit as well. And also, we have other publicly available database like the LOVD. HGMD is not publicly available. It's quite pricey and you have to have a prescription. The OMIM is publicly available. We'll talk about ClinVar. Many of you know about ClinVar. And some clinical and research lab have the data, and hopefully they will share the data and the literature as well. So the IARC database first released in 1991. It was maintained by Pierre Henault and now by Magali Olivier. And it includes both germline and somatic mutation data sets. However, no assertion to clinical significance is provided, but they have a general category, like the patient, the families are distributed under Li-Fraumeni syndrome, Li-Fraumeni-like, family history of cancer, or no family history. Now, ClinVar is an archival database that aggregates information. And it's an NIH-funded and maintained by NCBI. It launched in 2013. It mostly includes germline, but beware, sometimes they include somatic. It has assertion to clinical significance. So ClinVar, it's like a hub for researchers, for clinical lab, for expert groups, for clinics, and for patients. They all deposit the variant in ClinVar as well, and ClinVar will submit the variant on this freely available website. And also ClinVar does link to OMIM, CFTR2, breast information core, Insight for colorectal cancer, and Pharma G knowledge base. And like the CFTR2, the Insight, and our database with expert curation. Also, ClinVar is partnered with ClinGen. ClinGen as well is NIH funded, and it's a huge resource. The goal of ClinGen is to understand the human variants and to promote the application of clinical genomic and precision medicine. The ClinVar as well use a star-rated system for the variant that they are deposited. For example, let me give you an example. For example, if a lab X, Y, or Z deposit a variant, let's take an example, like arginine 283 histidine. For example, if one lab called it likely pathogenic, did not provide any criteria, it will receive only 1 star. If 2 labs submitted with criteria, it will move up to 2 stars. But if the 2 labs are inconsistent, one called it VUS and the second called it likely pathogenic, then it will go down to 1 star. The 3 star are when it has an expert panel curation. And this exists so far for cystic fibrosis, Insight, Enigma, and PharmGKB. And from the ClinVar website as well, they did they have expert curation now for P10 and for the rasopathy. And I think they are working on TP53. So now we'll give an example from the clinic. And here it's a consult that I will share with you. It's a 49-year-old, recently diagnosed with breast cancer. Pathology showed infiltrating ductal carcinoma, ER/PR positive, HER2 negative. And I just looked at my email to get more information about the tumor, and I was surprised to know that she had 3 separate foci. They called it multifocal, 1.2, 1.8, 1 centimeter. They did not say multicentric. There is a difference between multicentric and multifocal. Not everybody will make the distinction because multicentric may indicate it's like bilaterality, so the risk for heritability would be higher, but I could not find this information. So anyway, let's go to her family history. It's abbreviated. This is the only thing I received. She has a dad that has small cell carcinoma of the lung at an older age, and a granddad who died from malignant melanoma at 58 years of age. So a next generation panel testing has showed that she carries a mutation, arginine 267 glutamine. So, and here it is. These are all the variants or the mutations in IARC, the version 18, the new version of IARC. And this mutation is not a hotspot mutation, but it is present in 21 entry in the new version of IARC, and it is in a DNA binding domain. So in IARC, this is how it's such an easy, friendly website to use and quite informative, even if we do not have clinical assertion. But it shows, I can't see from here, but it shows that transactivation it has partially functional or partially deficient, and it's not a dominant, it does not have a dominant negative effect in assays. So next, I went to ClinVar, and I put this variant in ClinVar, and it has conflicting interpretation. 2 labs has called it likely pathogenic. 1 lab has called it likely pathogenic. Is that correct? 1 lab has called it likely pathogenic, and 2 labs has called it VUS. So the report generated from the lab who did this NGS testing on this patient has called it first likely pathogenic. And then when they reviewed their internal data, they downgraded to VUS. So anyway, And here are the criteria about the evidence that would support likely pathogenicity. So the criteria are, as you see in the slide, from the literature, one non-classical Li-Fraumeni syndrome family. Another child was described who carries this mutation, but as well he carries two other mutations, and this patient was reported by Kwasnel, David Malkin, Fraumeni, and Jude Garber. And so this mutation was in cis and in trans with each one of these mutations. Then the evidence in terms of population frequency, the minor allele frequency is low in the LAPS cohort, and this mutation is not present in 1000 genome or in exome variant server, which is part of the NHLBI. And in terms of conservation, it is evolutionary well conserved. The in silico, which I usually don't give much weight on it because most of the time are not consistent, but here they showed that it is slightly damaging. Now let's go to the supporting evidence for VUS. They reviewed the data and they concluded that it was present in a 74-year-old unaffected family member as well, so no segregation. And then they called it a partially functional. In the first report, they called it partially deficient. It depends how they see whether half full of or half empty glass. For me, I see it half empty. So anyways, internal structure analysis is not destabilizing. And the minor allele frequency, when they reconsulted their internal data that are not shared, is higher, 0.01%, but it's still higher than the cutoff point that we usually use as 0.1 in our clinic. So therefore, now it was downgraded to VUS. And here is the functional data on this arginine 267 glutamine transformant from the publication by Kwasnel and a colleague, and it is a red transformant. Now, all the evidence I presented, you can now, rather than going to the busy tables that I showed first and struggle with it, you can now, we have what we call pathogenicity calculator that was launched as well by ClinVar, and it's available to everybody. The Baylor team has done this pathogenicity calculator, and it's so easy. Just you put your variant and you hover over any of these rectangle, and it will give you the criteria based on the evidence. So here it is. If you see PM2 absent from control, so you place it under moderate pathogenic, and here, if well-established functional studies show a deleterious effect, then you click on the calculator, and it will give you the final call, likely pathogenic. Now, if you modify the evidence and you add some allelic data, because you know that it was observed in either trans or cis, and it's a dominant variant, now it's supporting benign classification. But if you click on the calculator, the calculator now is confused. It downgraded to VUS, but it's conflicting evidence. So this is a neat tool to use as well in the clinic. So we are left with a variant that we need the expert to, the basic expert that we have here in the clinic to tell us whether it is likely pathogenic or VUS, because that impacts the screening. She has 3 foci of tumor in her breast and downgraded it to VUS. Then she will not be eligible for surveillance screening. So To narrow down the problem, common reasons for not reaching consensus in variant interpretation and for conflicting interpretation of pathogenicity is the weight of functional data that us as a clinician or clinical molecular pathologist, we lack the expertise that you guys provide here in this room to classify this variant. So this is a big problem in terms of variant interpretation, no matter how many guidelines we have. And the second one is a weight of published data in the literature. And the third one is internal data that usually are not shared. We need to freeze the data and share the data while respecting the HIPAA. Now, the second one, I was interested to see how the variants that are deposited in IARC, how they are classified in ClinVar. So, in IARC, the most recent version, the 18, they have 360 unique variants, 885 families, approximately 3,000 entries. For germline, I'm talking only. So these are 360 unique variants. In ClinVar, they have 374 variants. Now, 111 variant from IARC are as well submitted to ClinVar. So we have clinical assertion for these 111 variant. I will skip through the slide for the sake of time. But these variant, this 111 variant in IARC that are submitted to ClinVar, 43 are assigned as pathogenic, 24 uncertain significance, 20 conflicting interpretation. So you have 44 conflicting and VUS versus 43 pathogenic, and if you want a percentage, 39 pathogenic, 39 between conflicting interpretation of pathogenicity and uncertain significance. Now, these 111 variants, as you expect, most of them are missense mutation. And we have, I mentioned, we have 20 variants with conflicting interpretation of pathogenicity. I will not go through this chart, but I will go back to our patient. Here she is, 300 arginine to 67 glutamine. Three families are reported in IARC. The first family, the proband is 4 years old, with a diagnosis of adrenocortical carcinoma. The second family, the proband no age available. She had breast cancer. The third family, the proband at age 2 developed rhabdo, at age 10 developed brain cancer. So these are, the first rows are compiled from IARC, the other row from ClinVar. In IARC as well, it shows that this variant is partially functional. It does not have a dominant negative effect. I'll give you another example. The arginine 282, yes, sure. And I'm about to be done, in fact. The arginine 282 tryptophan, it's a hot spot mutation, too many families to include in this rectangle, but the transactivation, it shows it's non-functional and it has moderate dominant negative effect. In ClinVar, it has one submitter who called it likely benign and 4 called it pathogenic. So we have a problem, and probably because of the functional diversity is impacting the way we interpret the P53, because we know it is diverse function from loss of function to gain of function, dominant negative effect, pH sensitive, temperature dependent, and supertrans, and you name it. So my last question and my last slide that's standing between you and dinner, but it's an important slide. So how can we resolve the issue? It's through formation of a TP53 expert panel of curator, apply ACMG rules as the framework, but tweak the ACMG rule to accommodate specifically the TP53, and generate a minor allele frequency threshold, define experimental evidence that are relevant to P53, and consider integrating somatic tumor when available, and professional judgment from life expert and other expert to remain key to address unresolvable differences in interpretation. And with that, I would like to thank you and thank my colleague at St. Jude, and I'll be happy to answer questions.
Make just a statement. This was great, and you clearly pointed out an important problem in variant interpretation in P53. There's actually a ClinGen working group that's been newly formed, and several people from groups of other, from within your groups are already on the panel, and we're happy to have more involved. Just contact me. I'm Sharon Savage directly, and
Sure.
This group is forming. So it's actually formed, and we're getting started on the curation.
Sure.
Okay.
That's great. I was just going to make a comment about the committees too for ClinGen.
Yes.
There's a separate committee to address the issue of utilizing somatic data for germline calls.
Mm-hmm.
So Dale's actually part of it from St. Jude, and so I think that again, more the merrier because we're in early days. The other point just to make is that there are a lot of people here involved in this, but some may not be aware. There's a registry called PROMPT, which is Prospective Registry of Multiplex Testing, and I'll discuss a little tomorrow, but it really pulls patients into the process to provide their reports and phenotypic information, because it is such a dynamic process and things change, so to get a phenotype-genotype correlation. So it's a study, I think, that fits some of your questions.
Sure. Thank you, Michael.
Go ahead, last question.
Yeah, sure. My name is Greg Harper with the LivingLFS.org organization. Recently went through a reclassification, my wife and daughter, from likely pathogenic down to VUS, which kind of really threw things up in the air. And for us, that means right now scanning, but in the future, that'll mean things like CAUTI-2, which is going to be expensive. When they do come up with cures, we really need to figure this process out so that we can make sure that we're making the right decisions.
Absolutely.
And the other part of it is spending a year thinking that it was likely pathogenic, when if we had known up front and the standards hadn't changed, we may not have spent a year living through that also.
Yeah, so the psychosocial consequences that are not trivial. Yeah. Well, I'll use this one. Oh, there we are. Thank you all very much. Where's dinner? Downstairs. So down the escalator? Down the escalator to the left. We'll be happy to carry on any of these conversations longer. Thank you all for your attention, and another great day.